Build a Furniture is a 3D VR game with the main objective of two players working together to find furniture pieces in a warehouse and build furniture in the living room. Due to some technical difficulties with hardware, we had to change our target platform from using the VR headset and controller to using desktop with mouse and keyboard. The concept of our game involves two roles, a builder in the living room environment and a finder in the warehouse environment. The builder is responsible for putting the furniture pieces together and relaying information to the finder about what pieces are required from the warehouse. On the other hand, the finder is responsible for finding the relevant furniture pieces in the warehouse and sending them to the living room via the shipping platform, as well as relaying information to the builder about what symbols on the furniture pieces should be put together. Order does matter in this game. We have also implemented sound effects for the environments, successfully putting pieces together, attempting to send the wrong pieces, and spawning pieces in order to improve user feedback while interacting with in-game elements.
The catalog defines the game. The builder clicks on a piece of furniture from the catalog in the living room, which updates the TV screen for what components are necessary for the first step, then the second, and so on as the furniture is built. In the warehouse, the finder will see the instructions update on the drop box. We must explain to the builder how the pieces connect.
As a reminder of what our warehouse looked like in our proposal, here is the original design composition. This is where the finder player will be looking for furniture pieces. And now here is what the warehouse looks like in our final product in the upper right image. We have made a lot of changes since the alpha and beta. This involved researching warehouses, creating a mood board, and identifying common colors in a warehouse. This is shown in the bottom left image. Since the initial design, the colors of the environment are considerably more neutral and the space has been reduced. A smaller model size helps in reducing loading time, and having fewer rows of shelves provides more space for the finder to move around. Similarly, an update was also made for the living room environment. Here is the original design composition for the living room environment. This is where the builder player will be receiving pieces and building furniture. And here is how the living room looks like in our final product in the upper right image. We revised the color scheme of the living room to be more consistent and to follow a theme, highlighting only some parts of the room with bright pops of color, while maintaining neutral tones overall so as not to be overwhelming to the viewer. Additionally, the space in the living room has also been scaled up to make it feel less cramped for the builder to work in.
The application requires many small pieces that could each have multiple snap points, and each snap point has an image. But these objects had to be spawned dynamically, on demand for both the builder and finder while remaining consistent. The best solution we could find was to create a template JSON file that held the important data for all the furniture pieces and a specialized serializer that takes in this data and converts it into A-frame entities. In addition to this, the bounding shapes and snap points all had to be manually placed and created for each individual piece, which was incredibly tedious. The biggest challenge was the snapping functionality, which continually caused issues or required more functionality throughout the development process. As the A-frame physics system cannot handle reparenting physics objects every time a snap occurred, the child piece would have to be duplicated in its entirety, including other snap points on the child, and then attached to the parent piece using relative positioning and rotations on the two snap points to place the new body. As one object cannot consist of multiple dynamic physics bodies, the bounding shape of the child piece would also have to be added to the same parent object. The markings on the piece help visualize how and where pieces are snapped. Previously, as seen on the right, we used an emissive map to show this, as it was visible anywhere despite light levels. However, the problem was that they needed to be small enough to be covered up post-snap so that they don't remain visible afterwards. As a result, in certain cases, they turned out to be too small to make out the symbols. Our solution to fix this was by connecting larger images of the symbols to the snap point themselves. They now appear large and obvious when spawned in, as they should, but will disappear once the snap is complete. A minor challenge we found branches off from adding images to snap points. We use a sphere to detect the collision or intersection of two snap points, which are essential in making the whole mechanic function. Any attempt to hide them only creates this effect of a transparent surface on hover. Another challenge we faced had to do with the orientation of the pieces being snapped. This issue arises in certain cases where an object snaps to two different points at once, such as on the chair's backrest. Another case is when the object is mirrored on both ends of the furniture, such as with the shelf sideboard. As seen here, because there are two snapping points and only one is ideal, there's a chance that the object will snap to the wrong component and create a mess. There is no way to detach pieces, so the only option is to restart. Were we given more time and personnel, there are several things we would add to improve the experience of our game. This includes a detachment element that allows the users to remove pieces off of furniture in case they make mistakes. In other cases, another is a trash can to delete components entirely if the player wishes so for any reason. This would also help avoid clutter and not being able to do anything to pieces after they've been spawned in the warehouse. We would also improve the movement of how smaller pieces are being controlled. While large blocks are easy to drag and move around, smaller pieces such as legs and skirts are not. We would also fully implement VR. We were unable to do this as a result of time and resource constraints, but a lot of our movement and controls are designed for VR in mind. As an aside, we would also add a crouch mechanic for desktop users to lower their camera view and view objects from below when they're on the floor or on a lower level of the scaffolds in the warehouse. Finally, we would also be adding more furniture of varying complexities.